Hello, my name's Ellie and I work for Manta Trust in Bar Atoll. I'm really excited to talk to you today about our paper, Sublethal Injuries and Physical Abnormalities to Maldives Manta rays, which was published earlier this year. So the Maldivian Manta Ray Project is the founding project of Manta Trust, and it was started in 2005 in Bar Atoll. We have 4 regional project bases in Bar, Ra, Laviani, and Lamu atolls, and we seasonally collect data in Makunadu and Formula. We're also really grateful to receive countless citizen science submissions from across the Maldives. Manta rays worldwide are vulnerable to sublethal injuries caused by human activities. For example, being hit by boats or entangled in fishing lines. A sublethal injury is one which doesn't cause death, but leaves a manta ray with permanent scarring, disfigurement, or missing tissue, which remains visible for the rest of the animal's life. While manta rays and other elasmobranchs do have a speedy capacity for wound healing, the long-term effects of these injuries on their health and fitness is an important gap in our knowledge. Our study greatly improves our understanding of the relative impact of different types of threats to manta rays in the Maldives, and we suggest conservation management actions needed to better protect them. Our study was based on over 73,000 photo ID sightings of the 2 species of manta ray, so oceanic and reef, collected in the Maldives between 1987 and 2019. By visually analyzing these images, we were able to determine injury frequency, identify injury types, and categorize them as either anthropogenic, so human-related, or natural. Any injuries which we couldn't identify were recorded as unknown, and multiple injuries to the same individual which clearly originated from the same event, so multiple fresh shark bites, for example, were grouped together for our analysis. Using generalized linear mixed models, we looked at the relationship between injury occurrence and the variables sex and maturity status, so juvenile or adults, for both species. And for reef manta rays only, we added the additional variable of site function, so cleaning, cruising, or feeding sites. Also for reef manta rays only, we investigated spatial trends in injury occurrence by calculating the percentage of injury events recorded per sighted manta ray in each Maldivian atoll. We identified 7 different injury types, and I'll just briefly go through how to recognize them now. So manta rays are susceptible to boat strikes because they spend a lot of time on the surface, particularly when they're feeding. So boat strike injuries are usually to the dorsal surface, so the top side of the manta ray, and quite often you'll see a series of parallel lacerations or scars from the boat propeller, with one larger perpendicular laceration or scar from the boat's keel. Injuries from fishing line entanglement are usually straight-edged knife-like slices to the head, mouth, cephalic fin, and the leading and trailing edges of the pectoral fins. If the monofilament line, say from troll line fishing, is wrapped tightly around the cephalic fin, this can cause amputation in severe cases. Injuries from net entanglement are usually extensive damage to the dorsal surface and around the edges of the manta ray, so the leading and trailing edges of the pectoral fins. For example, you can see in the right-hand picture a series of equally spaced slices, which is from entanglement in the net. Injuries from rope entanglement are usually similar to those from fishing line, but the slices are usually thicker, and often the injuries are more localized to the cephalic fins because this is where entanglement in mooring lines most commonly occurs. Moving on to naturally originated injuries. So manta rays have relatively few natural predators, except for large predatory sharks like tiger and bull sharks and some cetacean species. And predatory bite injuries are most commonly a semicircular bite wound to the trailing edge of the pectoral fins, but it can occur on other parts of the body also. These can leave manta rays with sections of missing tissue, or even in severe cases, truncation, so shortening of the pectoral fins. Deformities can include a misshapen head, mouth, cephalic fin, or even a severely bent or wavy tail, which can't be attributed to any other injury type in this study. And finally, in the infection, disease, and parasite category, these can include lesions, scarring, or damage to the gill slits or gill chambers, which can be caused by infections or even from repeated intrusion by remoras seeking shelter inside the gill chamber. So moving on to our results and injury profiles for both species. For reef manta rays, 29% of the 4,901 identified individuals had sublethal injuries, with over 1,600 injury events recorded. And for oceanic manta rays, 20% of the identified population had permanent injuries, with over 140 events recorded. Predatory bite injuries were the most common injury type for both species, with entanglement in fish's line being the most frequent anthropogenic injury. Boat strikes were comparatively low in frequency for reef manta rays, and none were recorded for oceanic manta rays. Our GLLM results showed that for reef manta rays, juveniles were 20% more likely to have an injury than adults. Males were 26% more likely to have an anthropogenic injury than females, and injuries were also more likely to be observed at cleaning stations rather than feeding grounds. For oceanic manta rays, neither sex nor maturity status were significant explanatory variables. Moving on to spatial trends, so for reef manta rays only, our results showed that North and South Malé, Bar, Adu, and Lamu atolls had the highest percentage of anthropogenic injury events recorded per reef manta ray. And this includes fishing line entanglement, boat strikes, and net and rope entanglement also. Predatory bite injuries were most common per sighted manta ray in Laviani, North Malé, and the northernmost atolls. I'm just going to go through and discuss some of our key findings. And if you would like to have some more information, then our paper is available open access on Frontiers in Marine Science. So as we just went through, anthropogenic injuries per sighted manta ray were most frequent in the busiest atolls, where tourism, fishing activities, and boat traffic are most frequent and most concentrated. Our GLMM results showed that juvenile reef manta rays are particularly vulnerable to injury, and this is likely because they spend a lot of time in shallow lagoonal habitats, which serve as nursery grounds. And these shallow, easily accessed areas are usually extremely busy with boat traffic, development, fishing activities, and tourism. Males also spend more time than females in these areas for reasons like predator avoidance and reliable foraging opportunities, and they likely have a higher risk of anthropogenic injury in these areas because of it. Our spatial trends showed that fewer predation injuries per sighted manta were recorded in Bar and Ra atolls, and this is likely because these areas have experienced higher shark fishing pressures before the shark fishing ban in 2010. Surveys across the years have suggested that shark fishing in these areas have led to population declines of large predatory sharks, the types that predate on manta rays. And finally, for oceanic manta rays, sightings and re-sightings of this species are much less common than for reef manta rays in the Maldives. So this is likely why our GLMM results were non-significant. So what are the long-term implications for an injured manta ray? So although they have a high capacity for wound healing and they're pretty resilient to even severe injuries, these injuries have the potential to impact their health and fitness in the long term. For example, a truncated, so shortened pectoral fin or a trailing fishing line or net could impact their swimming efficiency or make them more of a target for predators. A missing tail could impair their ability to detect a predator approaching from behind. A missing or dysfunctional cephalic fin could impact their ability to feed successfully, and damage to their reproductive organs could impair or even prevent reproductive success, which could have implications at the population level. So finally, in conclusion, globally, sublethal injuries add pressure to populations which are already threatened by targeted fisheries, incidental bycatch, the climate crisis, and tourism pressures. This is the first time a study has attempted to categorize all the sublethal injuries and physical abnormalities to a manta ray population for both species. And while manta rays in the Maldives are protected nationally and have never been targeted by a commercial fishery in the region, we show that incidental bycatch and boat traffic present significant threats to these animals. And while demand for reef fish, tourism, and boat traffic continuing to increase in the Maldives, it's likely that injuries to manta rays will become more frequent, which could lead to implications for their health and fitness in the long term. So, conservation management actions needed to better protect manta rays throughout their range should include no-take fishing zones and speedboat restriction or exclusion zones in areas of critical manta ray habitats, so feeding and cleaning, aggregation sites, and juvenile nursery habitats. Thank you for listening. Do you have any questions?